Well, good morning, everybody. Welcome to physics. We have a little lab today, and here's some notes that you're going to have to absolutely understand. By the end of the day, you'll understand this for sure. These are 3 questions that I'd like you to answer. So, if you see, this car here has an initial velocity, and it also has acceleration. Okay, so here's your velocity. Here's your acceleration. Right here is point A. And on the displacement scale, it's at -2, it looks like. So the 3 questions you have to answer are, when will the car stop? How long will that car stop? And when will that car arrive at point A? It should say point A, but it says point. Okay, so those are the 3 questions that you have to answer, okay? Okay, so the question, when will the car stop? Who has anything to offer in that area? Andrew. After 3.4 seconds? At 3.4 seconds is the correct answer, right? Because look, we've got a velocity. Oops. We've got a velocity here. We've got a velocity here of 34 meters every second. That means after 1 second, if that car remains at that velocity, it's going to go how many meters? 34. Very good. Okay. But we have an acceleration of 10 meters per second squared. Now, if you put this into one of your formulas, just the way it is, what's going to happen to your velocity? Well, if you would put this into your formulas, just the way it is, as a positive number, it would show an increase in velocity, right? But why do we know it's not a positive number? Because it's in the opposite direction, which isn't backwards or forwards, up or down, but the opposite direction of the velocity. So, remember that little checklist we did? Is this car going to be slowing down? It is, right? And that's why Andrew in his head could say, well, after 1 second, it's going to be 24 meters per second. After 2 seconds, it's 14. 3, it's 4. And then 0.40 meters per second. Right? Any questions on that? Does that make sense now? Okay. So for question number 2, how long will the car stop is the question. Okay, so we've already done some mathematical, stuff in our head. We think it's going to go about 57, 58 meters down the road before it hits 0 meters per second. We did that in our head. But the question is, the more important question today, how long will this stop? Any answers? For an instant, thank you very much. Whoever offered that up, that is exactly right. An instant. Okay, right? Because an instant, it will be at 0 meters per second. Does acceleration stop? No, it doesn't. So, 1 instant in time, it's 0 meters per second. The very next instant, what's going to happen? It's going to increase its speed, but going the opposite way. So this thing's going to go this way, stop, and then start coming back, right? Okay, so for number 3 now, that you probably understand the question a little bit better, since it already is at point A, when will it arrive back at point A is the question. So this is a symmetrical problem, which humans like symmetry. That's why we can have a problem with nature, because it's never symmetrical. We always want to think it is, but every time we go down that path, it just doesn't work. So what happens here? 3.4 seconds to get out there to that instant where it stops, right? Okay, now in order for it to get back to point A, which is going to be when it achieves this 34 meters per second, right? Because the whole 0 to 34 is the same as if you go 34 to 0, right? It's still an average velocity. It still takes the same amount of time if we have the same constant acceleration. So what's going to happen then is it's going to take 3.4 more seconds to get back to that exact same spot. So the right answer then is 6.8 seconds is when it'll arrive at point A. Okay, do you have any questions on that? Okay, so let's look at these graphs then here, down at the bottom. And I want you to explain what is happening in these graphs. Okay, so you should be getting pretty good at this. We've been working with graphs a lot. I'll give you a minute to look at them first. Okay, here's the big question then. Who's going to offer up what's happening in this graph right here? And you have to include direction and description. Najee. Starts out with a positive velocity, and what happens? A constant what? It's constant slope, which if I have a velocity time graph, a constant slope means I have a constant what? Acceleration. Very good, Najee. Okay, and it starts at a non-zero velocity, and according to this, it ends at a higher velocity. That's why we know it's a positive acceleration, positive velocity. How about on this graph? Who wants to tell me what's going on in this one?
It starts out as a positive velocity. No, yes, and then it decreases speed to slow down and stop.
Okay, so do we have an acceleration here?
Yes, negative acceleration.
Very good. So it starts out as a positive velocity and with a negative acceleration, and at the end of the graph, it has come to a complete stop. Okay, and how about the third graph? What are we seeing in the third graph? Who wants to explain the third graph? Okay, so the answer was you're starting with a negative velocity and you have a negative slope on the velocity time graph, which shows that we have a negative acceleration. So the signs of the acceleration and velocity are in the same direction. This thing is speeding up. Very important to know. That's a perfect answer. And then last but not least, this graph right here. Yes, you guys are really getting the hang of that. It started out as a positive velocity with a negative acceleration, comes to a stop, and then at that stop, it turns around and it starts increasing in speed in the opposite direction. Okay, that's very good. So with that, we can begin our lab.